Hi everyone, today we're going to talk about quartiles and creating box and whisker plots, which is a visual display of information about data sets and what the quartiles of the data sets are. So we won't get too deep into all the details about quartiles, but I'll just let you know that roughly speaking, quartiles basically divide all your data up into a 25% set of the data. So basically into quarters. Now you might ask, not all data amounts of data are divisible by 4, which is true, but we don't really need to worry about that in grade 9. If you want to know more about it, you can take data management or AP statistics in your upper school years. Okay, so basically what I'm about to show you how to do is to create a 6-number summary of a set of data. The 6 numbers that we're going to be looking at today are the min, max, range, Q1, Q2, and Q3 values. So what Q1, Q2, and Q3 do is basically signify the barriers between the quarters, the quartiles of data. So let's walk through this with an example. Okay. So you can see here that I have a data set of 9 points. And the first thing you need to know about calculating all these values and creating a box and whisker plot is that these numbers need to be in order. So I'm just going to write them down. And as we can see, this is just a sequence of numbers from 19 to 27. Okay. And we'll start with the second quartile. It's very easy to find. It's the median, which we talked about in a previous class. So I know if I have 9 data points, I can count over 1, 2, 3, 4, 5. And I know that this number is the one that's directly in the middle. So my median of this data set is the number 23. Now I can see that there are 4 pieces of data below 23 and 4 pieces of data above 23. So the next thing I'm going to do is I'm going to find the first quartile. So what I'm going to do is take the median of these 4 values. And if you remember, if we have an even number of numbers, the way we find the middle value is by taking the average of the 2 that straddle the middle. So in this case, I'd be taking the average of 21 and 22, which turns out to be 20.5. Now, something I didn't mention is we didn't include Q2 in the lower half of the data or in the upper half of the data, and that always happens if we have an odd number of numbers. If we have an even number of numbers, Q2 would be an average value, so we wouldn't have to worry about that. We'll see an example of this later. So I'm going to do the same thing to calculate Q3. It's the average of 25 and 26, which is 25.5. Now the other 3 numbers that we're going to find, the first 2 are very straightforward, as you can imagine. The min is 19 and the max is 27. Now this data set is evenly spaced, so not too exciting. But soon we will be seeing data sets that aren't evenly spaced, and you can see why the min and max value actually matter. Okay, and what is the range? As you can imagine, the range is the difference between the max value and the min value. So it's really easy to calculate. I just subtract the max from the min, and I get 8. So that tells me the difference between the highest value and the lowest value. Now what we're leading up to is a visual display of this data, which comes in the form of a box and whisker plot, which is kind of a cute name because these guys here look like cat whiskers. The picture that I'm showing you right now is a little bit rare in that it looks really, really symmetric. So when we get into actual real life box and whisker plots, oftentimes they won't look this nice. You'll see on the next page. So what I do on a graph, I would actually line these numbers up along a number line. And in this case, I would line up my minimum value with 19. I would line up my lower quartile Q1 with 20.5. My median is 23. My Q3 value is 25.5, and my maximum is 27. Okay guys, on this page, I'm presenting you with a variety of box plots, and what we can deduce from the box plots here is that the box plots show average monthly temperatures for a year in degrees Celsius, so that includes all four seasons, for 5 cities: Waterloo, Hong Kong, Nairobi, Reykjavik, and Lima. So what I'd like you guys to do now is pause the video and use the information in these graphs. And maybe I'll start you off with the first one, even though it's the easiest one. When I look at box plot A, I can see that my lowest temperature is -3, and my highest temperature is 27. And you know, I've lived in Canada all my life. I think from experience, I can tell you that this is probably, of those 5 cities listed, that this makes sense that the information belongs to Waterloo. So I will provide you with the correct answers after, but I want you to take a few minutes amongst yourselves and try to figure out which box plot goes with which graph. And feel free, if you'd like, you can use the internet to help you. So get to it, guys, and I will reveal the correct answers in 2 minutes. All right, guys, and we're back, and hopefully you have talked amongst yourselves. And the grand reveal is the following: B is Hong Kong, C is Nairobi, D is Reykjavik, and E is Lima. Okay, so let's answer some quantitative questions about these box plots. Which city has the highest median temperature? So median refers now to Q2. So we know that Q2 is going to be the line that's right in the middle of all of our box plots. So if I take a look at all of these, I can see that the highest median temperature belongs to Hong Kong. What is the smallest temperature range? So that would be the spread between the lowest and the highest value, temperature value, and I think we can see pretty clearly that that feature belongs to Nairobi. And describe the temperature in Reykjavik. We can see that it is pretty cold, I guess, pretty cold, not as cold as Canada, pretty cold, and it has a small range of fluctuation. Okay. So all of this is really cool, but your job now is going to be to learn how to draw these box plots, box and whisker plots, and we're going to show you how to do it in 2 ways. The first way is by hand, and the second way is using graphing software called Desmos. So we're going to get to that in a minute, but first let's do it by hand. So in Milan, Italy, great place, the monthly temperature averages are 6, 9, 14, 17, 22, etc. Create a box and whisker plot for Milan at the top of the previous box plots. Use this space for your calculations. So the first thing we have to do is put this data in order. So let's do it here. I have 6, 6, 9, 11, 14, 17, 18, 22, 24, 26, 29, and 29. Good. Okay. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. So we have an even number of data pieces. So to find Q2, which is what we should do first, we should be finding the median of, and I'm going to count over, it should be the middle 2 pieces of data. So we've got 1, 2, 3, 4, 5, 6, 7. So I have 1, 2, 3, 4, 5 pieces of data here, 1, 2, 3, 4, 5 pieces of data here. So it's going to be the median of 17 and 18, which is 17.5. Now Q1 and Q3 should come next. So Q1 is the median of the bottom half of the data, but now since we didn't Since this is an even number of data, what I have to do now is consider all 6 data points below this red line, so below 17.5. So we don't include Q2 in the bottom half of the median, but 17 is not part of Q2. So 1, 2, 3, 4, 5, 6. I'm going to take the median of 9. Median of 9 and 11, which is 10. All right, and what about Q3? 1, 2, 3, 4, 5, 6. I'm going to take the median of 24 and 26. And 26, which is 25. Okay, now we need the min and the max. So the min value is 6, the max value is 29. All right, so I'm going to cheat here for a second because I can copy and paste my data. Let's go to the next page. Okay, and let's draw this box and whisker plot up here. Okay, so I know my minimum value is going to be 6, so let's draw it right here. 6, and of course, please use a ruler. 6. My Q1 value is 10, so I know the start of the box is going to be here. My Q2 value is 17.5. 15, 16, 17.5. Okay, and then 25 is my Q3 value. So here is the box. Draw that a bit nicer. Here's the box. And 29 is my top data value. Alrighty, so that is our first box plot by hand, box and whisker plot. Okay, so what I'd like you all to do, I'm going to pause here, and I want you to either use this QR code or you can click on the link from your lesson package. I'll also post it on Schoology. You'll also need to go to Schoology to get this spreadsheet. So I'd like you to open your laptops now, go to Schoology, and you're going to click on this really short, it's a 5-minute video on how to actually create a box and whisker plot. And I will meet you back here when you are done that work. All right, guys, so we've met back here, and hopefully by the end of this, what you would have seen or what you would have come up with is something that looks like this. Okay, so I'm going to just observe, and we'll talk about this in a sec, but you might notice that there's a circle way out here on the outside, and I'm going to talk about that in just a second. But what we're supposed to do with that dot is actually ignore it. If Desmos has not included it in the box and whisker plot, it means that it's deemed an outlier, meaning that it is so far off of the other medians that it shouldn't be counted, or it should be separated out of the data. Okay, so in this case, this woman's height, I believe, was 198 centimeters, which is too big of a jump from the person shortest, or the next tallest, I guess, from her. And so she is not included in the box and whisker plot. Okay, so let's just answer some questions here. We should have calculated the min height, the max height, the median Q1 and Q3. Forgive me while I go back to Desmos for a moment to look at my data again. So I am getting that the max height is 198, min is 149, and of course my numbers are different than the one Ms. Hancock had because she deleted some data. 165, 177. All right, great. All right, and we've got a title on here. Excellent. Okay, so Now we can see that if we have a spreadsheet with data at our disposal, it's really easy to make a nice box and whisker plot. We don't even need a ruler. Okay, so it's very easy if you have the data in a list. All right, so now that we've made our box plot, let's answer the following. What is the median height of female Canadian Olympians from 2012? Is this taller than the height of an average Canadian female? You'll have to look that up online. For reference, 5'6" is 167.64 centimeters. And when you plotted the box plot, it automatically chose to exclude the outliers. So toggle that button and let's see what we think that means. So let's go back to Desmos and let's have a look at that. Let's see what I can fit in this window. So the next question asks, when you plotted the box plot, it automatically decided to exclude the outlier. So we can actually go back, and I just wanted to show you this. We can go back there and actually choose not to exclude outliers. So we can include that piece of data in our box and whisker plot. All right. What do you think this means? Well, it just allows us the choice to include that piece of data or not, but it does eliminate sort of the information given by the distance. So when I have my box plot, let's say it looks like this. I have an outlier out here. What it tells me is that there are no heights between those 2 points, whereas if I were to copy and paste this, okay, and if I were to just include the outlier, it doesn't give me that information. So I don't know that there's a big jump between here and here. So the outlier helps us see that the tallest woman was actually quite a bit taller than the second tallest woman at the Olympics that year. Okay, we know that there are the same number of women from Q1 to the median and from the median to Q3. What do you notice about the range of the second and third quartiles? So let's go back to our numbers. Okay, so what do we know? So from Q1 to the median, Q2, they're the same number of women. Now, there might be repeated number of women with the same heights. So, you know, we can't really count how many women are in there without going back to the spreadsheet. But the question is not asking us that. It's asking us, what do I notice about the range of the second and the third quartiles? So let's look at Q3. So Q3 is 177. So we can see that there's a difference of 5 centimeters. So I have 25% of women between 165 and 170 with a range of 5 centimeters. And then this range is a little bit bigger. Okay, so that just tells us that the spread between Q2 and Q3 is a little bit larger than the spread between Q1 and Q2. Okay, so I hope this was informative. I don't think you would have seen this anywhere, but it gives us new information about data sets, and soon you'll be able to answer questions about, you know, ranges and what this means. And we can also look at some skewing. So what does it mean when one of the quartiles is really thin compared to the other ones? So guys, your job is to do the homework. You're going to do it at home and submit it on Schoology tomorrow. And as usual, if you have any questions, come to Extra Help and feel free to go see any teacher in the morning who is available. Good luck.